There's going to be 3 steps that we are going to have to follow to complete a stoichiometry calculation. So the first step is we always have to look at the reaction given and make sure that it is balanced. So we're going to do a quick check about that. The second is we're going to identify the compounds discussed in the question and determine the mole ratios between them. And the third step is, depending on what's given, we're going to perform the necessary gram-molar conversions, meaning grams to moles or moles to grams. Okay, we may have to do a couple of conversions, or we may have to do one. It all depends on what the question is asking us. So the example is right here. I will box it off so that we see it. It says, given the equation 2H2 plus O2 gives us 2H2O. And it's saying you react 20 moles of hydrogen gas, that's the H2, with 10 moles of oxygen gas, which is the O2, and it's asking how many grams of H2O will you end up with. Our first step is making sure it's balanced. So quickly, how I like to do it is I like to write out all of my elements on the reactant side because they're going to be the same as my product side. So I see a hydrogen and I see an oxygen. I like to write it right below the arrow so that I can go on each side and list out how many I have. So for a hydrogen, I can see I have a 2 coefficient and I have a 2 subscript. I'm going to multiply the 2 and get 4. So I have a total of 4. Ooh, sorry, that's a highlighter. I have a total of 4 hydrogens on the reactant side. And then on the product side, same thing. I have a coefficient of 2 and I have a subscript. And I know that what that means is that this is going to be distributed. So I also have a 4. So far my hydrogens are balanced. Now I'm going to look at my oxygens. On my reactant side, I don't see a coefficient, I just see a subscript. So that means that there are only 2 oxygens on my reactant side. And then on my product side, I can see there is a 2 in front, no subscript, and I know that if a coefficient is in front, it not only distributes to the first element, but it also distributes to the second. So I would have a total of 2 oxygens on my product side. So for step number 1, we just quickly went through it and we saw that it is balanced. Now I can go to step number 2. So I'm going to identify the compounds discussed. So they are talking about hydrogen gas, which is H2. I'll write that down. They are talking about oxygen gas, O2, and they are saying that it creates H2O. So that is our product. So now what we're going to do is we're going to look at our reaction, and I will highlight our reaction on top. Right? There we go. And we're going to see the mole ratio between them. So if I'm looking at just hydrogen to water, that's right here and right here, I can see that I'll write it here, H2 to H2O, there's a 2 coefficient in front of both. So that means that there's 2 moles of H2 and 2 moles of H2O. Always, always, always reduce. So that is the same thing as saying there is a 1-to-1 mole ratio of H2 to H2O. So let's do the mole ratio of oxygen to water. So O2, I will circle, circle it in a different color. So now we're looking at O2 and we're looking at H2O in red. So I'll write that here. So O2 to H2O, I could see the coefficient. O2 has a 1 coefficient when H2O has a 2, so it's going to be 1 mole to 2 moles, or 1 to 2 is our ratio. Our third ratio, because it just told us to do the mole ratios of all the elements that we wrote down, so our last one would just simply be the ratio between the H2 and the O2. So I have H2 to O2. I can see it is a 2-to-1 ratio. So for step number 3, it says perform necessary gram to molar conversions. I'm just going to write down all of my givens so that I have it clearly written. So in the question, it says you're going to have 20 moles of H2. It says you have 10 moles of O2. And then what you're not given, or you're unknown, what we need to find is going to be how many grams of H2O. So we're going to use our mole ratio to help us answer this question. We are looking to answer grams of H2O. So I'm going to focus on my ratio between H2O and H2 because it's a 1-to-1 ratio. So that means if I have 20 moles of H2, that's going to equal 20 moles of H2O because of this 1-to-1 ratio. So what I'm going to do is I'm going to use this 20 moles of H2O to solve my problem using the equation given. So the equation given is number of moles equals given mass over gram formula mass. So our number of moles we figured out is 20 moles of H2O. What we are looking for is our given mass, mass of H2O, so X grams of H2O. And what we have to do is we have to put in the gram formula mass of H2O, which when you calculate it should be around 18.02 grams per mole. Just a recap, H is about 1, there's 2 of them, O is about 16, and you add them up to get about 18 grams. I'm simply going to solve for X now, and sorry, I'm just going to move the screen. And what I'm going to do is I always just put this over 1 and I will cross multiply. So it would be 20 moles times 18.02 grams per mole equals X grams of H2O. I'm going to multiply 20 times 18, get about 360.4 grams of H2O as our X, and our moles get canceled out when we do the math. And this is our final answer. On this second practice problem, they give us a reaction and they're saying how many moles of sodium sulfate will be formed if you start with 200 grams of sodium hydroxide. So they're showing you right here that's sodium hydroxide, and you have excess of sulfuric acid, and that is our sulfuric acid. Okay, so here we go. Our first step is simply to just check if our reaction is balanced. So what I'm going to do is I'm going to write out each element. I have an Na, I have an O, H, S, awesome on both sides. So if I go across Na, I can see there's 2 Nas here, 2 Nas here. O, I can see there are 4 right here, and then there's 2 right there, so that would give me a total of 6. On this side, this 2 also would distribute, that's 2, and this is 4, so this would also be 6. Hydrogens, I'm looking at 2 hydrogens here, 2 hydrogens here, that's a total of 4. And this would also be a total of 4. So far everything is balanced, but let's look at our final element. S is by itself, 1, and S is by itself here, another 1. So step 1 is complete. We have a balanced equation. So our second step is going to identify the compounds that they're discussing and talking about and determine the mole ratio between them. So if we look at the question, they're saying how many moles of sodium sulfate, so that's going to be our first compound that we are focusing on, will be formed if you start with 200 grams of sodium hydroxide. So that's the second element we're focusing on. And they say, and you have excess of sulfuric acid. So this, I circled it before, they're just saying that you have like an infinite amount of it. It just keeps going. So we don't really need to know this compound. So we're only sticking with the 2. So I would write down NaOH is the first compound I'm focusing on, and the second is Na2SO4. So if I want to look at their mole ratios, what I'm going to do is I'm simply going to look at the coefficients. So in front of NaOH, I see there's a 2. In front of Na2SO4, I see there's nothing. So I can always assume that that's a 1. So it is going to be a 2-to-1 ratio. The third step is you're going to have to do the calculation. So I'm simply going to write down my given, makes my life a little easier. The given is 200 grams of sodium hydroxide, which is NaOH. And they are asking you, our unknown is to solve for how many moles of sodium sulfate. So that's Na2SO4. So my first thing is to start with my given. I have 200 grams of NaOH. I need to use my calculation to turn this into moles. So that means I'm looking for however many moles of NaOH. And if I use my table T, I know that that is given mass over the gram formula mass, or the molar mass. So my given is 200, so I'm going to put that on top, 200 grams. And my gram formula mass is going to be about 40 grams per mole. And remember, I have to find Na in the periodic table, O, and H, and add them all up. Once I divide these two, I get an answer of 5 moles of NaOH. So I'm going to use this information and I'm going to use my mole ratio and combine it to solve for what they're asking, which is moles of sodium sulfate. So I know from step number 2 that there's a 2-to-1 ratio. So that means for every NaOH to Na2SO4, that's going to be 2-to-1. So I'm just going to set this up in a proportion to figure out what is my missing amount of moles. So NaOH is on top, Na2SO4 is on the bottom. So that means what I solved for before is right here, 5 moles of NaOH, so that would be 5 moles of NaOH, equals X amount of moles of Na2SO4, and that is what I'm looking for. So this I'm simply going to have, and I'm going to solve for X by cross multiplying. So that would give me 5 times 1 equals 2X, and X would equal 2.5 moles of Na2SO4. So remember what we did right here is we simply converted what we had in grams into moles. So that was that NaOH of moles. Then we used step 2, which is our ratio, a 2-to-1 ratio. If we knew there's 2 NaOH to every 1 Na2SO4, we plugged in what we figured out as 5 moles into our NaOH right here and solved for our X, which is Na2SO4. Our last problem we're going to do is how many grams of lithium nitrate will be needed to make 220 grams of lithium sulfate. They give us a reaction. Again, we're going to do the same steps. So for this one, let's look at it. We gave you the blanks. This is kind of like a hint. It's not going to be balanced. You need to balance it. So let's do the same thing we've been doing. Underneath the arrow, I'm going to write all of my elements. So I have a PB, I have an S, I have an O, Li, and an N. So I'm going to go step by step, counting how many I have of each to see if it is balanced already. PB I see as 1, I see it's 1. S. On this side, remember there's a subscript, so that gets distributed to everything. So I have a total of 2. S on the other side, I have a total of 1. O, I have a total of 8. On the other side, I have a total of 12. Li is 1 to 2, and N is 1 to, this gets distributed, 4. Now you can actually keep all of the polyatomic ions together too. That could be an easier way, but I'm just going to split it all up so that we can do it one by one. So far PB is balanced, S is not balanced. So I'm going to come in with a different color, and I see 2 on the reactant side, so I'm going to put a 2 on my product side. That's going to change everything up. So that gets distributed to every element in the compound. So now Li has going to be a total of 4, S is going to have a total of 2, and O is going to be 8 on this side, and it's going to be 12 on the same side, giving us a total of 20. So if I were to look at this so far, PB is the same on each side, S is the same on each side, O is different, Li is different, and N is different. So I'm going to go on my reactant side, and I'm going to put, I see Li and N need a 4. So I'm going to put a 4 as a coefficient. That's going to distribute to everything. So that means there's going to be 4 Li, 4 N, and a total of 12 O's on this side, and 8 O's on that side, which gives me 20, and I am balanced. I'm going to just erase a lot of the arrows so that you can see it is 1, 4, 1, 2 as our balanced equation. In the question, it said how many grams of lithium nitrate, so I know that's going to be my first element we're talking about. That's going to go in my molar ratio. So I'm going to write down LiNO3 from my equation. Lithium nitrate will be needed to make whatever amount of grams of lithium sulfate. So lithium sulfate is going to be my other compound that I'm comparing. So it is Li2SO4. And what I'm going to do is look back at my equation and see the coefficients. In front of the LiNO3 was a 4. In front of the Li2SO4 was a 2. And I always reduce. So it's a 4:2 ratio, which is the same thing as a 2:1 ratio. Third step is the math part. So I'm going to write down my givens, what was given in the problem. We don't have the problem in front of us, but I'm just going to write it out for you so that you know. It's asking how many grams of lithium nitrate will be needed to make 220 grams of lithium sulfate. So lithium sulfate is Li2SO4, and it tells us there's 220 grams of it. It's saying assume you have enough lead sulfate to perform the reaction, so we don't have to worry about lead sulfate. But our unknown, what we are trying to find is how many grams of lithium nitrate, which is LiNO3. So my first step is I'm given moles of Li2SO4. So my first step would be just to convert that to moles. So moles of Li2SO4 would be the given grams, which is the 220. So I'd write 220 grams on top, over the gram formula mass, which means you'd have to take Li times 2, S, and O times 4, add them all up to get a gram formula mass of about 110 grams. When you divide the two, you get 2 moles. So this would be gram per mole, sorry. And 2 moles of Li2SO4. So if you have 2 moles of Li2O4, what I'm going to do is I'm going to look back at my mole ratio, and I know it's a 1:2 ratio, meaning Li2SO4, if there's one of them, there's going to be double the amount of LiNO3. So that means for every 2 moles of Li2SO4, I'm going to have 4 moles of LiNO3. Now, the question is asking us for grams of LiNO3. So what I'm going to do is I'm going to plug this into the same formula I've been using. So if I were to just write that formula down, just so that we all remember, we're looking at table T, it would be moles equals grams over gram formula mass. So the moles are given to me, so I have 4 moles of LiNO3. It's asking to find the amount of grams. So you're looking for X, and you're going to look at your reference table or your periodic table, and you're going to do the gram formula mass of LiNO3. So you find Li, you find N, you find O, and you multiply it by 3, and you should get around 69 grams of LiNO3. Simply going to put this over 1, cross multiply. Let me just make my screen a little smaller. What you get is 4 times 69 equals X, and X equals 276 grams of LiNO3, and we are done. So this is kind of the hardest problem you're going to see because it was a 2-step problem, but I hope this helped you guys.